In order to understand a little bit about on how the value of stock works, we need to understand something different than an annuity. As an annuity gets longer and longer and longer, we'll have a single payment which is going to repeat again and again and again. And the more of those payments that we have, the larger the value of that annuity is going to be. But it doesn't grow at a steady rate. As we add one more payment on to the end of an annuity, the value of that annuity is going to grow by a smaller amount each time. And what's really going on is that the value of each individual payment, if you were to compute them separately, becomes smaller as n increases. In other words, the further away a payment is, the smaller that individual payment is worth in terms of present value. Consider the computations on the screen. If all of the time value money factors are unchanged, PV is going to get smaller as n increases. If we're looking at a $100 payment that's going to be happening over and over and over and over again, we could see that if we require a 10% rate of return, a payment that's coming due in 1 year would be worth $90.9091. A $100 payment that's coming due in 5 years would only be worth $62.0921. A $100 payment due in 20 years would only be worth $14 and a little more than 86 cents. If we look at the value of a $100 payment that's going to come to us 100 years from now, that's worth less than a penny. It's worth 0.73 cents or $0.0073. If you look at the chart, what you're seeing is a picture that represents this. The value of each payment gets progressively smaller and smaller until they get closer and closer to zero. If n gets large enough, the present value of a single cash flow becomes almost zero. If you consider the value of a $100 payment 1,000 years out, you've got this long string of zeros and then finally a non-zero digit. So it's worth a little bit more than zero, but not significantly more. And ultimately what happens is with a little bit of math, we're able to simplify the formula for this perpetuity, for an annuity which does not end. And we can kind of round off everything that happens after a certain point, and our formula simplifies itself. If we're looking at an annuity which doesn't end, or a perpetuity, we're going to compute the value of that by taking the cash flow, which is expected, and dividing it by the rate of return. If I were going to draw a timeline of a perpetuity, I'd draw it this way. I would have my normal-looking timeline, but I'd put an arrowhead on the end indicating that it's going on, quote-unquote, forever. Consider a $100 annual perpetuity for which we require a 12% rate of return. Rather than trying to discount an infinite number of cash flows, we're going to use the perpetuity formula that I introduced to you. So the present value of that perpetuity is going to be our cash flow divided by our rate. Our rate of return is 12%, so I take 100 divided by 0.12, our $100 payment, divided by 12%, which gives us an answer of $833.33. That's the amount that you'd be willing to pay right now to receive $100 per year forever if you required a 12% rate of return. If your rate of return was higher, the value of that perpetuity is going to be smaller. If we required a 15% rate of return, we would be willing to pay less for that perpetuity. And if we only required an 8% rate of return, we'd be willing to pay more for that perpetuity. So again, the value is going to go up and down on the other side of a sort of a seesaw effect with the yield that we're seeing. So the rate of return and the price are going to go up and down against one another. When one goes up, the other will go down. But a perpetuity itself isn't necessarily valuable. What's happening over time is that the value or the spending power represented by that cash flow is diminishing. Interest and other factors are going to be eating away at the value which that cash flow has. And so investors really want a cash flow which is not only going to continue for a very long time, but they want a cash flow which is going to increase every year. So consider the following situation. An annual perpetuity of $100 next year, but which is going to grow 10% each year. You still require a 12% annual return, and our timeline would wind up looking like what's shown on the screen. At the end of period 1, we'll have a $100 cash flow. At the end of period 2, it will be $110. At the end of period 3, it will be $121. So each cash flow grows 10% of whatever it was before. As long as that percent growth rate is constant, this formula will give us the present value. The present value of a growing perpetuity is going to be the next cash flow divided by the difference between the rate of return and the growth rate. In this case, our next cash flow, the cash flow at time 1, is $100. Our rate of return is 12%. Our growth rate is 10%. So the difference between them is 0.02 or 2%. 100 divided by 0.02 is equal to 5,000. What this tells us is that expected growth has value in the eyes of investors. Clearly, you'd pay more for a perpetuity which was going to grow than you would for a perpetuity which does not grow. And when we're looking at a significant amount of growth, 10% in this case, the difference in value is significant. Now, there are a couple of rules that we need to use for this formula. First of all, R is always going to be greater than G. The rate of return which an investor is going to demand is always going to be greater than the growth rate. If the growth rate is expected, there has to be something in addition to that growth rate which the investor expects to compensate for the uncertainty around that perpetuity, for the risk of that perpetuity. So R is going to be greater than G. Mathematically, if G was ever greater than R, you'd wind up with a negative number in the denominator of your fraction, and this would give you a negative number as the value of your perpetuity, which would never happen. That would be akin to saying to somebody, I've got a stream of cash flows which is going to be $100 next year and growing 10% every year, and I'm going to pay you money to take it off my hands. You'd never do that. So the formula will also work for a perpetuity with zero growth. So the sort that we saw before, when growth equals 0, we can still use the same formula, but R minus 0 is simply R. So it simplifies back to the formula that I showed you before. If you're building a note sheet to do the homework and be ready for the exams, what I recommend you do is you put the formula that's shown on the screen into your notes. The present value of a perpetuity is equal to the next cash flow divided by the rate minus the growth. And make sure you tag it with the rule that R is always greater than G, and remember that it will still work for a zero growth perpetuity.